Okay, class.
Yes.
Yeah, it's not a good one. And that was almost a Calvin right there. Yeah. Yeah. Huh? Yes, Calvin. Anyway, so we are on page 45? Yeah, 45 in our notebook. So you're writing this on there. Now, this is the packet that I gave you last week. So this packet right here, I already gave you all the notes for 4.1 to 4.4. So please open up this one. So this is where the note packet is. It starts here, it looks like this. So please make sure this is out. And then we're going to flip a couple pages over to the first one. All right, does anyone need more copies of this? Yes? All right, come on down. Anyone else? More copies? There you go. There we go. All right, so starting the notes over here on the first example. So first example for this says, label the valence at each vertex in the graph below. Label the valence. What is a valence? If you flip over a page, you could actually find the vocabulary for valence. What you got?
The numbers of edges meeting at a vertex.
Very good. The number of edges meeting at a vertex. So the edges would be the lines, where the valence is all the lines going to that point. So I'm going to go through and start numbering them to see how many edges we have here. So we have 1, 2, 3, and 4. Yes? Yes. Those are all the edges there. And now let's look at this next one for B. Let's do the same thing. So we have 1, 2, 3, 4. Yes, I know that there's more down below this, but I want to go through and tell you because you're going to help me with the next ones. It says, identify whether each graph is connected. If not, explain why not. I'm going to back it up. Let's go down to our definitions. Connected graph. Connected graph is right here. Every pair of vertices has at least one path connecting them. Every vertices, which is every dot, has at least one path going to it. Okay? That's telling if it's going to be connected or not. Now let's look. For A, can you tell me, is A connected? You're shaking your head? Is that a yes? Okay. Anyone else? Yes? He says yes. Calvin? Yes. Angel? Yes. Gabriel? What did you say? Yes? Everyone's yes? Anyone not say yes? What about this loner? Does every vertex have a line, at least one connecting it? No. Because we have a loner over here that doesn't have a pathway or an edge going to it. So this one is not connected. Explain why not. C is not connected. Now, let's do B on this one. Let's answer the question. Is B connected? Yes, they all are connected over here. So for question B, they are all connected. we go. And write connected or not connected, because when you come and look at this later on, you're using it on your test. You don't want to have to go through and read all the questions. You could actually just see this is connected, that is not connected. So that's a good example when we take the next test. All right, I'm going to give you a couple moments. I want you to do C, D, and E right meow. All right, did you go through and number them all first? You got to number all the vertices, balances, edges. Hey, I got a question for you. Seriously. How do you make a tissue dance?
Blowing it.
You put a little boogie in it. All right, let's go through. And I'm going to go through and start numbering here. The vertices are not labeled already, but I'm just going to go through and number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now, yes.
I did it a different way, but I still got it all.
Yeah, it's fine. It's fine. There's more than one path on any of the Eulers. But this one's actually not asking for a Euler. It's just asking label all of them. So that's why I colored it as I went. And then now, is this connected? Yes, it is connected. It doesn't have any that were left out there, right? So this is connected. Now let's take a look at the next one. Now, for D, is D connected? Yeah, it's all connected. We don't have any that are missing. We're just checking to see if all of them have roads going to it.
Okay, sorry, it's from my vision so bad.
No worries. Right here on this first example, see this person living at point C? There's no road going to their house, so they're not connected. So all these other people in this neighborhood, they're all connected by at least one road, so they can go back and forth there. That's what it is.
Alright. I was gonna do an Apache Junction joke, but.
Oh yeah, none of those are connected.
No, yeah, all the way by itself. Oh, wait.
Hey, do me a favor. Tell those kids to go back to class. Are those your kids?
Yeah.
Weren't there like 5 of them sitting right there?
They must have left, because Jay came by.
Oh, good. Good job. All right. So let's take a look. So we said it is connected. That one is connected. And for E, go through 1, 2, 3, 4, 5, 6, 7, and 8. Is this one connected? Yes. Now, for this next one here, it says practicing Euler circuits. Practicing Euler circuit. Determine whether a Euler circuit exists. Let's pretend like I paid attention last week. We're just pretending at this point. You don't have to, throw anyone under the bus. What has to happen for a Euler to exist? Start and end at the same spot. That's very good. Anything else with that?
You can't retrace it.
Cannot retrace, right? Cannot go over a line more than once. Now, to test to see if something is a Euler circuit before I try and figure it out, how do we have to test it? What do we do to test it? Go ahead.
Count the edges.
The edges, right? The vertices at every point, right? So let's go ahead and do that. So we're going to determine if it exists, identify your starting vertex, label the direction and edges you use. So we're going to use some numbers, and then never use an edge more than once, and link between two parts of the graph still need to be covered. So let's take a look on this one. I'm going to just go through and start numbering. How many edges does this first one have?
2,
2. This one has
3, 4,
4. This
2, 2, 4, 2, 4.
Okay, is that all of them? Okay, so what has to happen for this to be a Euler?
It has to be even numbers.
Awesome. You're just on it today. Good job. So it has to be even numbers. Are all these even numbers here?
Mhm.
Yes, there are. So I could say, yes, a Euler circuit does exist. A Euler circuit does exist. Now, we just have to go through and try and figure it out for ourselves. So I would like for you people to go through and do this one here on your own. Okay, I'm going to go down and see this next one here. We're going to count this one to see this next one. So this one, there is a Euler. Let's look at B. Let's go through and start counting B. So I have 2, 2, 4, 2, 2, 4, 2, 2, 4, 4, 4, 2, 2, 4, 4, 2, 2, 4. Is that all of them? All right. So now, I look at all those numbers. Are any of those numbers odd? No. So that means that it could be a Euler circuit here, right? You just have to go through and try and figure out your path. So this one's kind of messy, but I think you could do it. And let's see. Let's look at this one right here. Let's count them. So right here we have 2. Over here we have. How many's here? 3. How many down here?
2,
And
3.
all right. So what can I automatically say about this?
It's impossible.
It's not. It's not a Euler's, right? So I could automatically say not Euler's. So that means that you people are going to fill out for A and B, because I'm pretty sure everyone is going to have a different path on these ones. So I want to see some at least unique ones, not just copying it off the person sitting next to you, like someone in here is doing currently. But good job, you guys. And don't forget, like, share, and subscribe. Hit that notification button. Follow my Instagram